Hello, geometry folks. Today we are going to take a jump into area formulas. So, a lot of these you may remember from middle school or even elementary school, but it's still worth going over again. Some of these formulas are going to be brand new, but all of these formulas are things that you should commit to memory as much as possible. Now, is it true that in real life you can look it up? Yes, that's absolutely true. But don't just ignore them and have to look them up all the time. Try to store some of them in your noodle. Let's go. So if we are going to look at areas of polygons, let's start with the easy ones. If I want the area of a rectangle, you guessed it, the area of a rectangle is base times height, or in this picture, W times L. However you want to remember it is okay by me. Area is base times height, which is the same as length times width. You can multiply it in any order, call whichever one the base and whichever one the height you want. Well, what about a triangle? Guess what, kids? A triangle is half of a rectangle or half of a parallelogram, but it is going to be half as big as your rectangle. So the area of a triangle is 1/2 base times height. Or, wait a second, what do you mean, or, Mrs. Weber? We learned a new area formula this year. What if you have a triangle and nobody told you the height? But they said, you know what? We're going to tell you how big an angle is. One of the new area of a triangle formulas is that area equals 1/2 AB sine C, which means you can find area by doing 1/2 the product of two sides and the sine of the included angle. 1/2 AB sine C. All right, let's go. What about a parallelogram? Well, a parallelogram is just like a tilted rectangle, and a parallelogram has the same area formula as a rectangle, where area is base times height. Just make sure your height is that perpendicular height and not this A value, the slanted height. I don't want that. I got to do base times regular height. All right. Now, let's do a trapezoid. I don't know if you've ever learned this area formula or not, so we're going to learn it right now, and I am going to do some math magic right in front of you. Here we go. The area of a trapezoid. When you have a trapezoid, you have two bases, base 1 plus base 2. Those are the parallel sides in the trapezoid. And if you know the height, the area is h over 2 b1 plus b2. And if you're thinking, wait a second, why on earth would you do that? I am going to show you. Here we have, I don't know, like a squarish thing. I'm going to turn this squarish thing into a trapezoid. To make a trapezoid, I just need one pair of parallel sides and one pair of not parallel sides. This is a trapezoid. And if I go a little bit further with this, I am going to mark on it that this thing up top is base 1, this thing on the bottom is base 2, and this thing right here is the height. Do you agree? I agree. There's base 1, base 2 times the height, and the height. Well, wait a second. Why do I add the bases and multiply by half the height? Watch this. I'm going to take this trapezoid. I am going to fold it in half. Wha! Thereby taking half the height. Then, not only am I going to fold it in half, I am going to cut it in half. Wha! Base 1 and base 2, and the height's over here. Watch what I can do with this. Do. Boom! What on earth just happened? Well, I know what happened. I made a rectangle, and the area of this rectangle is base 1 plus base 2 times half the height. So, kiddos, the area of a trapezoid comes from cutting the trapezoid down the middle and rotating it to make a rectangle. But what if I didn't rotate that way and I rotated the other way? That's okay. I would still have a parallelogram, which is base 1 plus base 2 times the height, just like the rectangle. Ta-da! All right, so trapezoid, h over 2, b1 plus b2, and I will put the math magic away. Now, what about a rhombus? Well, a rhombus is really just a parallelogram, so the area of a rhombus is base times height. But a new area formula for a rhombus is your rhombus can also be 1/2 the product of the diagonals. So if you know the length of the diagonals, the area of a rhombus is 1/2 their product. Why, you ask? I'll tell you. One of the properties of a rhombus is that the diagonals are perpendicular. And so what I get in a rhombus is I get 4 congruent right triangles because this equals this and that equals that. So what I could do to find the area of a rhombus is I could find the area of this triangle and then multiply it by 4. Well, the area of that triangle would be base times height divided by 2. My base would be d2 over 2. My height would be d1 over 2. And then if I divide that by 2, I would get d1 times d2 over 4 over 2, which is really d1 times d2 over 8. Well, I have 4 of those. So d1 times d2 over 8 times 4 is d1 times d2 over 2. In other words, I can do 1/2 the product of the diagonals because the diagonals are perpendicular and they create 4 triangles. So that's where that formula comes from. What about a circle? Well, the area of a circle, we've done that before. That's area equals pi r squared. No surprises there. What about a regular polygon? Well, the formula for the area of a regular polygon is 1/2 AP, where A is the apothem, that's a fun word, and P is the perimeter. Now, if I can't spell perimeter, there we go, I need an R. What? Well, number one, what the heck's an apothem? Not an opossum, opossum, apothem, apothem. It's a fun word to say. The apothem, think of the apothem almost kind of like the radius of a regular polygon, but it goes from the center perpendicular to one of the sides, not to a vertex. It goes to a side and it's perpendicular to that side. Well, if this is a regular polygon, meaning all the sides and all the angles are equal, what I could do is I could turn it into a bunch of triangles. So what I could do there is I could say, you know what? Why don't I just find the area of this triangle and then multiply it by the number of sides I have? So if I looked at just this triangle here, let's call this side S, the area of that single triangle would be S times A divided by 2. Well, I would then have to multiply this by the number of sides I have, which is 1, 2, 3, 4, 5, 6, which is 6s times A divided by 2. 6s would mean take all the s's. That's the same as the perimeter. So I'm doing perimeter times apothem divided by 2, which is 1/2 AP. Now, I spent quite a bit of time in these first couple of minutes showing you the math magic behind the formulas. And do I want you to understand that? Yeah, I do. If you don't, though, if you're feeling overwhelmed, I at least want you to know that these formulas came from somewhere. They didn't just drop out of the sky and we accepted them and said, okay, and so it is. No, we can prove why it is. Okay. But at the end of the day, I need you to be able to use the formulas base times height, base times height, base times height, or base times height divided by 2, or 1/2 AB sine C, or 1/2 the product of the diagonals, or h over 2 b1 plus b2, or area equals pi r squared, or area equals 1/2 AP. Know those formulas and be able to use them. Be able to use them how, you ask? Let's turn the page. All right. Now, at the top of the page, one of the other things we look at is perimeter. And just remember that you know that perimeter is the distance around a shape, and it's the sum of the lengths of the sides. All right. What do you do for the perimeter of a circle since there are no sides? Well, wait, a circle doesn't really have a perimeter. I call it something else. Oh, that's right. We call that a circumference. C equals pi d is the perimeter of a circle. All right, let's do this. So find the area and the perimeter of the parallelogram given below. Well, this is a parallelogram. So if I want the area of a parallelogram is base times height, which in this case is 20 times 12. and that's 240. Now let's talk units. I'm multiplying centimeters by centimeters, so that's 240 square centimeters. What about perimeter? Well, for perimeter, I just add all the way around. So I've got a 15 and a 20, and since it's a parallelogram, I got another 15 and another 20. So 20 plus 20 is 40, 15 plus 15 is 30, 40 and 30 is 7 centimeters. Now, everybody's afraid to ask this, Mrs. Weber, does that centimeter squared mean I square the 240? No, 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 no. It's just saying square centimeters, that you could fit 240 little tiles inside of the space. Okay, you do not square the 240, it's just the units that are squared. All right, find the area and perimeters for each of the triangles given below. I should have said areas and perimeters maybe for each of the triangles given below. Not sure where I should pluralize that. I have to ask an English teacher because my grammar's a little rusty. All right, so this first one, area is going to be base times height divided by 2. Well, my base is 7. My height is 4. So my area is 4 times 7 divided by 2, which is 14 square meters. And my perimeter here is going to be everything added up. So 5, 5.7, and then 7. So that is going to be 17.7 meters. If I want the area and the perimeter of the next triangle, I got to tilt my head a bit because they didn't give me the height here. But if I tilt my head, I realize that's a right triangle. And the area of a right triangle could be base times height divided by 2. So my area here is 1/2 base times height. And so that area is going to be 1/2 4.5 times 6. Now, you should have a calculator nearby, or maybe have Desmos open or your phone open. But as you do these problems, you are definitely going to need a calculator for some of them. In this sense, I'm being 13.5 square yards. And then if I want the perimeter, I just add everything together. 4.5 plus 6 is 10.5. Plus 7.5 is 18 yards. And now you have your triangle areas. Okay, next one says find the area and the perimeter of the isosceles trapezoid given below. It is not drawn to scale, so I'm basically being told to assume that these are the same. And so if I want the area, let's start with that. So this new area formula for a trapezoid is h over 2 b1 plus b2, which would be 8.5 over 2, 24.3 plus 9.7. So I'm going to pull out the calculator and type that in, 8.5 over 2, 24.3 plus 9.7, and I get an area of 144.5 square centimeters. And now I need the perimeter. Well, I have this and I have that, but I don't know the other two. Well, what I'm going to have to do here is I'm going to have to block this off and say, you know what? If this is 9.7 here, then this is 9.7 down there. And so 24.3 minus 9.7 is 14.6. And I've got to split that evenly to these two pieces. So I'm going to divide that by 2 and get 7.3. Okay. How does that help? It helps because now I have a right triangle. So I can find this side by doing a squared plus b squared equals c squared, which is 7.3 squared plus 8.5 squared equals c squared. And then if you go through that and solve for c, trust me, you're going to get 11.2. So my perimeter is 11.2 plus 11.2 plus 9.7 plus, what was that base before I split it up? Oh yeah, 24.3. And so if you add all of those up in the calculator, you are going to get 56.4 centimeters. Okay, looking good, looking good. All right, number 4 comes after number 3 for a specific reason. Number 4 says, find the area and the perimeter of the rhombus shown below. Okay, well, if this is a rhombus, I know that all the sides are equal. So for a refreshing change of pace, let's do perimeter first. That's going to be 4/15, which is 60 meters. And then if I want the area, I need base times height divided by 2, but I don't know the height. So maybe I can use the diagonals. All right, what do I remember about diagonals of a rhombus? Well, they cut each other in half. So if this is 12, that's 12. And here's why this followed number 3. I really, really want this. So if I want that, I can say, you know what? I can do a squared plus b squared equals c squared. And if I solve for x there, I'm going to do 15 squared minus 12 squared and square root it and get x squared equals 81. So x is 9. And so now, if I want my area, it's 1/2 the product of the diagonals. This diagonal is 24 meters long. This diagonal is 18 meters long. So I'm going to grab the calculator and do 0.5 times 24 times 18 for 216 square meters worth of rhombus. Okay. There was a lot going on there. All right. So now we have 5, 6, and 7. So let's take a peek. If you feel like you know what you're doing, I think that you'll be A-okay. And we're going to try the formula. So if you want to try it on your own, go ahead and then scrub through the video. Otherwise, let's go through it together. So it says find the area and perimeter of the regular decagon shown below. Okay, so this is one of those regular polygon things. Decagon, deca, oh, that means it has 10 sides. So if I want the perimeter, I can just do 8 times 10. So this is 80 inches for my perimeter. And then my area is 1/2 A, the apothem, P, the perimeter. Oh, it's a good thing we did perimeter first, huh? So area is 1/2 AP, apothem times perimeter. So the area here for this thing, if I pull out my calculator, or if I look at the answer key I made earlier, is going to be 492 square inches. Find the area and the circumference of the circle. Leave your answer in terms of pi. All right. Well, if that diameter is 6, my radius is 3. So the circumference is pi times diameter, or 6 pi meters. And my area would be pi r squared, which is 9 pi square meters. And last but not least, find the area and the perimeter of the equilateral triangle. Well, equilateral means that all these sides are equal. That's great. The perimeter is going to be pretty easy because that's just 3/8 for 24 inches. And now I need my area. Well, I could really use the height right now. That'd be helpful. Or, since this is equilateral, all the angles are equal. So the 180 degrees of a triangle gets split evenly 3 ways. These are all 60-degree angles. I'm going to use that other fun formula, 1/2 AB sine C. And so the area of this triangle is going to be 1/2 8 times 8 times sine 60. 1/2 the product of 2 of the sides and the sine of the angle in between. And if you type that into a calculator, you will get 27.7. And my units would be in square inches. So, what do I need you to get out of this? I need you to know how to use formulas. One of the things that I wasn't great about as I did this lesson, but I think you should be better about, is when you're using a formula, write the formula down before you start plugging things in, because it reminds you, well, what do I need? And then you start backfilling that information in. Okay? Write down pi r squared, pi d, 1/2 AP, and then find the pieces that you're missing. So, with that, I am all done. I hope everybody's having a good day, continues to do so, and has a good later on. Toodles.